So welcome to Transform Gov, the digital government podcast, where we tell real life stories of how technology and data are changing the way public services are delivered and designed. As always, we talk to people who are doing the real work, people who are on the ground, making that transformation happen. Transform Gov is part of the Ireland e-Government Awards, and it's brought to you in partnership with Accenture. And I'm Maeve Kneafsey. So today we're joined by Hitesh Tewari, who's the professor in Trinity College Dublin and also part of the ADAPT Research Centre. Hitesh looks at something every public service now really has to depend on, which is trust, okay? And as more government services are going online, the research focuses on how we can really verify identity, protect privacy and guard against fraud in this age of AI. He's worked in real-world projects, so this won't all be theory, in areas like digital identity, energy and climate data, and even voting systems. So I know it's intriguing. We'll find out more. So Hitesh, thank you for joining us on Transform Gov.
Thank you for having me.
So I know when we spoke earlier, you warned that AI can already pass many existing identity checks. So in simple terms, explain to us, what can AI do now that allows people to... I mean, it must be worrying for government if AI can replicate some ID documents and kind of get through the net.
Yeah, so just taking a step back there. So, a lot of companies and banks and other organizations want to do know your customer KYC verifications. And traditionally what's happened there is that you present some sort of PDF document or you present, your original document which they look at and take a scan of. But today what's happening is that, with AI technology, you can actually create replicas of your passport, replicas of utility bills, which are so accurate that vision techniques and AI techniques cannot detect whether or not is this a real document or is this a forgery.
That is so worrying, really, because we've got to a stage now where digital government, there's an element of trust in it, both sides. And do you think it's a big issue? Is it prevalent? Do you think, are we having a big number of incidents of people, pretending they're somebody they're not and AI creating those documents for them?
So there's no accurate numbers, but absolutely there are companies which are employing third parties to help them with this problem. So I've been looking at companies who are doing this sort of work, and they are now struggling with their traditional techniques like vision and, examining documents and looking at fonts and looking at where the logo is placed and so on, where, forgers can make mistakes. AI can just bypass all of that and make very, very accurate replicas that their techniques are just not able to detect. And how big the problem is, we don't know, but it's a growing problem. With AI being so accessible to everybody, it's so easy to do.
But are there ways that we don't just rely, we being banks and other people who are trying to verify identity, that we don't just rely on a document? We're also using verification to our mobile phones. Is it just that difficult to get? Rather the other way. Is it that easy to get through with a PDF document that looks real?
Yeah, so mostly it's done with documents, really, to be honest. In person becomes a problem in the sense that you require more manpower, you require more, money to be spent to do these verifications. So there are companies out there which will verify your identity for you if you go there in person and present some documents to them, and then they'll charge a fortune for that. You could if you imagine a digital cert that most of us don't own today. It costs in the region of $250 to get every year and renew. So that's the cost associated for business. So they don't want to go down that line. Yeah. They'd rather just do PDF documents being sent to them over electronic interface. And if they're genuine, then all good. But if they're not, you've got a trouble. You've got a problem there.
You've got a problem. So if it can be documents, it could be images, it could be video, and obviously they're convincing. So what does it mean for know your customer? I mean, how difficult is it to actually know somebody is who they say they are?
Yeah, it's near impossible with these sort of technologies. So what you now need to do actually is to go to the source of truth, really. That's where you have to go now. So, imagine that, I'm presenting you with my passport document. Well, instead of me giving you a copy of my passport, you now talk to the passport office directly on my behalf, and I authorize you to do that. Right?
So is that up and running, that kind of system?
No, not yet. Okay. No, but the research has been done. And what we're looking at is this idea. Again, the problem there is that, today, if I present you with my passport, I'm not presenting you with just the identification that I'm an Irish citizen. I'm actually telling you a lot more about myself.
Or personal information.
Yeah.
Because I can see it on your passport, right?
Absolutely. So you can see my date of birth, you can see, my gender. I may not want to read any of those things to you, and they're not necessary for you to verify that I'm an Irish citizen.
Okay,
right?
okay. So, let's go back to that in a second. But who or what kinds of public services do you think are most exposed with this risk? I presume it's things like healthcare.
Yeah. Healthcare. I guess the other is just with, consumer products as well. If you think of buying mobile phone contracts, maybe buying or getting your identity verified because you want a Dublin bus pass.
Yes.
And these sort of things, right?
Yes,
So,
of course, welfare, grants and payments.
absolutely, yeah. So, all these sort of things where there are transactions going to happen, where there's money involved, is ideal for these fraudsters to come in and try and exploit those systems.
When we were talking earlier before the podcast, I was thinking, well, does that mean that public sector services are going to start rolling back because of the risks? Or do you see them making, really trying to make an effort to deal with this?
I think that there is no way you can't roll back services. The services are there. You have to embrace the technology that's out there that can help you to do this sort of stuff. So if we have a situation where you are being scammed and fraud is happening, then you have to look at other mechanisms to counteract those situations.
Of course, it's scalable, this kind of fraud, isn't it? I mean, you mentioned there that there are people being hired in organisations just concentrating on trying to take an identity and pretend they're somebody else.
Yeah, absolutely. They're scalable. And you do it in one place. If you can do it, let's say in Ireland, it's more than likely the systems are so similar in the UK that, you could replicate those so easily over there and then across the EU and so on and so forth.
Okay, so now we're worried. But before we go back into how we can fix things and the way we can deal with it, let's just take a really short break for our partner, Accenture. We'll be back to you in about 2 minutes.
Through the power of cloud, data and AI, Accenture is helping the public sector by blending human ingenuity, technology and a delivery-focused culture to turn their ambitions into action. Be ready for any challenge by adopting a continuous reinvention mindset to deliver human-centric services that adapt and grow with your needs. Contact the team at Accenture to find out more.
So we're back on Transform Gov, where we're doing our second tranche of questions with Hitesh Tewari, who's from Trinity College Dublin, and also Adapt. And we're talking about AI being able to replicate identities and perhaps fooling organisations into thinking we're somebody we're not, right? Yeah. Or somebody stealing our identity, indeed.
Yeah.
So if we're having this problem and it's scalable, what way do you think we can deal with it?
So again, as I was saying, well, you can no longer rely on some sort of document sent to you across an online interface. So now you have to go to the source of truth, right? So if you're looking for someone's address and there's a utility company that has that information, then you go to the utility company directly and get that information from them. The problem for these companies is that their databases are sensitive. They don't want to release huge amounts of information to third parties. So now we need other techniques which allow the utility company or this verifier or this prover to tell you that, yes, this person has this address, or yes, this person is over 18 years old, or yes, this person is an Irish citizen, without revealing any other information.
Okay. So why wouldn't you reveal other information? Just give us a sense of what bothers people about that, or what the risk is.
Well, imagine you have a bank statement, right? So if I present a bank statement to you which has my home address on it, which is great, that I proved that I live at a certain address, but it also provides you with huge amounts of transactions as to where I buy my groceries, what sort of clothes that I buy, and so on and so forth. I don't want you to know any of that information, really. And that's where the problem is. So people want to kind of identify themselves, to third parties, but they don't want to reveal personal information about themselves.
Okay. So how do we, technology do that for us? I mean, I have had conversations with earlier guests where they talk about that we, the consumer, we, the individual, should own that data and give it out as we wish, rather than having to rely on going to the passport office.
Correct.
I mean, where do you see the ownership of that data relying?
If it's data that you think is owned by you, such as social media posts and so on, and that makes a lot of sense, where you own that data and you control that data. But if it's verification information, then that is owned by someone else who is a trusted authority, right?
Okay.
So you have to go to them to get it, because claiming that you're an Irish citizen doesn't mean that you are one, unless the passport office says so.
What about if we said we use something like MyGov as a central repository for all our personal information that is kept there? is that a possibility that we could use that as a way to verify?
Absolutely, and that's what a lot of governments are thinking. In the UK and Ireland, there is this kind of move to have this sort of information on your mobile phone where, a copy of your passport could be on your mobile phone and other sorts of documents could be there which you could use to prove. But again, the problem there is that when you show a copy of a passport, you're showing more than just the fact that you're an Irish citizen. It's revealing other information. So again, if we want to have a situation where we will only want to reveal very small amounts of information that the person requires, then we need other techniques here.
Yes. So talk to us about, I'm bringing up this word with reticence because it makes people think, I don't know, they can't switch off. Yeah. But let's talk about blockchain and the role it might play in really dealing with the problem. So maybe just explain to people what blockchain is or isn't.
Yeah. So blockchain came out of Bitcoin a long time ago, over in 2008. And what it does is that it allows a ledger. If you think of a bank today, a bank maintains a ledger, and it contains information about users who bank with this organization. And anytime someone transfers money from, Alice to Bob, there's a ledger entry that's happened, a transaction happens, and that ledger is central to the bank. And what Satoshi Nakamoto, who invented Bitcoin, wanted to do was to make everybody the bank.
Okay.
He wanted to empower all people who were involved in the transactions to be part of the system. So distribute the ledger. So everybody keeps a copy of the ledger. Okay. Everybody agrees, these are the transactions that have happened and these are good transactions. And people then kind of agree that the state of the ledger is at a certain point.
I suppose it's a bit like shared docs, isn't it? But I presume secure, that people can't fiddle around with it.
And the security part is the blockchain.
Yeah.
So all the transactions that are there are put into blocks, and these blocks are chained together using a cryptographic mechanism, which then means that if someone wanted to go and change a transaction maliciously, they have to do a huge amount of work to be able to make sure that the ledger remains secure and verifiable. And that was the key thing that Satoshi brought to the world of cryptocurrencies.
Yes. And so but blockchain can be applied to lots of different scenarios. And you're thinking in this scenario we just talked about that it could be applied in terms of identification or sharing information in a limited
Absolutely,
level.
Yeah. So let me give you an example of these sort of zero knowledge proofs that can be there, right? So so imagine a zero knowledge proof in a situation where we want to prove ownership. So I meet some person out there who claim they are part of a group that I'm involved in. So some group that I'm involved in, they say they're part of the group, but I don't know them. I said to them, okay, well, fair enough. Well, we have a safe. The combination of the safe is known by only the people in our group. I'm going to go in there. I'm going to put in a secret message into the safe. You go out and retrieve it for me. Right? If this person can do that, then they also know the combination to the safe. Then they are part of the group. So that's group ownership. So in that scenario, neither they or I have revealed the combination of the lock of the safe. So we are zero knowledge. So we haven't told anybody else about anything that we know secretly. But yet we've been able to verify that we are both part of the same group.
Okay.
So that's kind of a zero knowledge proving mechanism here, right? So that's kind of sort of thing we'd apply to these sort of scenarios. And then once the proof is done, because that's an interactive protocol that I talked about there a minute ago, both parties need to be present. We can't have that in a scenario where we want to prove our identity.
Okay.
So that has to be kind of a situation where the proof is kept on the blockchain, and then anybody can go and verify that proof.
So give us a scenario. Tell me a scenario where that's actually an action. What could somebody be looking for? What kind of identity?
So I'd like to prove that I'm over 18.
Okay.
And I go to the passport office, or I authorize the passport office to create a proof for me and put that on the blockchain. And then I go to a pub and I'm there. I'm saying, well, I want to get in there and buy a drink. The guy says, well, I don't think you're 18. I say, well, go to the blockchain and verify my identity there. And he says, yeah, okay, I see the proof. I verify the proof, and you're in.
And of course, you haven't shared other information other than the one thing that person asked for, which is what age are you?
Yeah, exactly.
Yes.
I didn't tell them my date of birth.
Yeah.
Right, which I don't want.
Yeah, exactly.
That sort of thing.
Yeah, exactly. So in terms of scenarios that we talked about, you also talked about blockchain in terms of verifying votes and people casting votes. I thought that was really interesting. I know in Ireland we don't obviously have our elections online or any online element to them, but there's lots of ways you can vote. And why is blockchain a good scenario to support that?
Yeah. So we are going to electronic voting, right? So that is happening. And,
Is
COVID,
it happening?
COVID definitely did it for us in Trinity.
Okay.
The provost election was there. I think it was 2020 or 2021. And we were in the midst of COVID.
Was that Linda Doyle's appointment?
Yeah.
Oh, very good. Okay.
And we couldn't do, a physical vote. Typically, the vote in Trinity, you have a conclave.
Yeah.
In Trinity, and they all get into a room. We stay there for 4 hours, and we
That's very unusual for Trinity to do something like that.
so we do have that, but we couldn't do that. So we have to do this electronically.
Yeah.
So electronic voting is like a black box system today, right? So the company that creates the voting process knows exactly who voted how, and it doesn't actually tell you.
You mean the people who are managing the technology for the voting?
Absolutely.
Okay.
They know exactly how people have voted because that's the way it is. And two, we really can't verify the voting process itself because all the company says is this is how the tally was and this is what our system said and here's the outcome.
Okay.
So there's no verifiability really. So we came across a cryptocurrency called Zcash. It's a bit like Bitcoin, but unlike Bitcoin, it's totally anonymous. So in Zcash, you can have a number of types of transactions. One is you can have a transaction from Alice to Bob, and both their identities are protected. You can also have a transaction from Alice to Bob in which one of their identities is revealed.
Okay.
And we kind of looked at that and said, that's an interesting way to do voting. Why don't we give everybody who's a candidate who wants to stand for election a digital wallet, a virtual wallet?
Yeah.
And everybody who we know can vote, and this is a closed use system such as the university where we know who the voters are.
Yes, it's verified. And
give them all a digital wallet as well, which is again virtual. And to each of the candidate voters, we just drop one Zcash token.
Okay, let's call it a coin.
A coin.
Here's your coin, you got to spend it. You've only one person you can vote for.
Exactly. Yeah. And then they each get an email. They click on the email, they go to a web page, they see the list of candidates, and they just click on the candidate. And what that does is that their Zcash token or their coin is transferred from their shielded wallet, where they are protected, to the candidate's unshielded wallet, and we can see who they voted for. But we can't tell who voted for whom.
Okay.
So the candidates' tallies are public, whereas the voters who voted for these candidates, their identities are kept secret.
Okay. And tell me, it may be obvious to everybody, but why is that important, that it's anonymous?
Well, that's how voting systems work. You do not want anybody to know how you voted. But at the same time, you absolutely need to verify how the voting took place and if the tally was correct.
And there's no fraud going on. It's one person, one vote.
Absolutely, yes.
Yeah.
And on the blockchain, again, because we're using a zero-knowledge proving mechanism, many people can come and look at the blockchain at a later date and make sure that the tally is correct. So imagine, when we're doing real voting in Ireland, you have all the parties and their, tally people tallying the vote as it's being cast. So in this scenario, you could have anybody come into the blockchain and verify the vote was done correctly.
Okay.
Yeah.
And I suppose we think about America now, they wouldn't like that. I know, because it's a very different system. People register with parties, and therefore their assumption is that they vote for them. But anyway, it could be applied in a very good way.
Yeah, and it allows you to vote on any issue instead of having this big process we do once for every 4 years. We empower citizens to be able to vote on issues, or at least express their views on issues that are of importance to them on a weekly or a monthly or whatever basis that we want them to do that on.
Yes, that'd be exhausting. Can you imagine the government trying to manage all that? Everybody's, what do you think every week? And then you have another project. Sorry, are you still working on that platform? The voting platform?
Actually, that platform's live and, anybody can use it for free. And where the hope is that somewhere down the line, some government agency is going to say, well, this might be an interesting thing that we might trial it out.
Okay, and what's the name of the platform?
It's called zkballot.com.
Is that Z and a K?
Yeah.
Okay, ballot.com. Okay, very good. And if it is being used now, who's it being used by?
It's mostly being used by things like, societies and, universities. Those sort of people want to use that sort of stuff.
Okay.
But, if you had a government which was really willing to do something in that area, then this might be the platform.
And also, everyone who's listening, if they want to try it out, it's there. And it could be used for something that, fairly unimportant, and see how the system works.
Absolutely, yeah.
Now, let's talk about greenwashing. Okay. So I find this fascinating. So tell us about the work you did with the ESB. Give people context about greenwashing and what the issues are.
Yeah. So ESB came to us with this problem they were seeing, and one of the things that happened very recently before we talked to them was that a company had been called out by one of the ministers in Ireland for claiming that all of the energy that they had used that particular calendar year was green.
And green being generated by sustainable wind, solar.
Absolutely, yeah. And the reason they did this, and this was they weren't wrong in saying what they were saying. They were legally was right, because there is something called a guarantee of origin certificate, which is a EU-wide document or instrument that anybody can use to buy green energy. Now, the problem with this instrument is that it can be bought up to 12 months after when it was produced.
Oh.
So, it could be produced in January, and a big corporation can hoover up large amounts of these go certs in December and say, for this year, all my energy was green.
But they couldn't have, because the energy's already burnt at that stage in December.
Absolutely.
Okay. Okay.
And that's the big problem.
Okay.
And so because ESB is a big player in the market and they control the grid, they were saying, well, is there a possibility to somehow at least make it a bit more, real time than what it is now? And we said, yeah, I think we can. What we think we should do is use a blockchain where it's all publicly known. We can see when the energy was produced and when it was consumed, and we can mash those two things up and say, well, if the grid had lots and lots of green energy at that time and it was consumed by one of these big, players, then more than likely a lot of it was green.
Yes.
And that was the issue that we helped them with.
And are they continuing to pursue that and
So the prototype was developed. We had a real wind farm and we had a real data center that was consuming it. We showed it to them and it all worked. The problem with the market currently is that the regulator is not enforcing this on the industry. So if the Go Cert is a EU-wide instrument that is legal, no player is going to move and change their systems unless they're forced to.
Because in a way you could end up being, or maybe that's the situation as it is now, that people are really trading.
Yes.
Rather than really buying.
Absolutely.
Green energy. Okay.
Yeah.
Okay. Well, obviously we can't change that today, but hopefully somebody will change it. Absolutely. Talk to us about healthcare and what you're doing at the moment, because I know you've got some projects you were going to share with us.
Yeah. So healthcare is another one, right? So there's all of this data that belongs to us sitting in silos in GP surgeries, sitting in hospitals and so on. Today, if I wanted to find all my healthcare data, it's not in one place. It's all over the place. And a blockchain is a really, really good mechanism where you could have all of this stuff stored. And if you could identify yourself to the blockchain correctly, then it could just pick out all of those pieces of information that belong to you. And suddenly you have all your healthcare data in one place.
I presume the electronic health records, hopefully they'll be underpinned, do you think, by something like this, some sort of blockchain solution?
Absolutely. And that's the hope. The problem with a lot of the people have at the moment is that these EHRs have personal information contained within them. So what we need to have is a situation where we can remove that personal information from that record, but still somehow link that record to the person. So that's where the trick is, where you can somehow.
Now you've lost me totally.
So if I remove all your personal information from your healthcare record and put it up on a blockchain, and you go looking for it, if your name isn't on that record,
I can't match it to me.
Yeah. But if there are techniques in there using all sorts of cryptographic mechanisms that can allow us to figure out which records belong to you, and we can extract them out still.
Okay.
So what that does is you still have access to all your records very easily. But two, if we can do that for every citizen in Ireland, what that means is we have a huge amount of data that was sitting in silos now on a public blockchain, and we can use AI techniques to mine that data to figure out healthcare trends, what's happening in the community. Are we going to see a flu epidemic this year? Those sort of things can be very, very quickly, ascertained if we have access to that data.
Yes, I can imagine. And I suppose that the big thing in people's minds when it comes to sensitive information about them is the security of it. And the big thing in government's mind and public sectors, the same thing. Yeah. They don't want to have some sort of awful situation where information is released. And I think from what you've been saying is that blockchain is a very efficient way and safe way of doing it. I mean, you're looking at, security risks and all of that. Do you feel it's the best mechanism out there in terms of sharing data?
The more eyes you have on the data, the more people that say, yes, this is, secure, this is the right data. That's when you get confidence. When you have things in silos and you don't have control over it, then it's very difficult to know any of that information. What the blockchain does is gives huge amounts of transparency. It gives us privacy if we want it that way. It gives us security. So all of those things can be built in using blockchains, which we never had before. So we had all these siloed databases. Now we can have all this information in the public, but still protect the identities of the people that.
I suppose it helps with GDPR compliance and sharing data across agencies, because they won't be able to associate necessarily easily the individual with the information, but they'll be able to get the information.
Absolutely. And, the blockchain is the GDPR for AI, really, if you think of it that way. With AI, you've got all sorts of people looking at data, trawling through data, but you also need protection. And the blockchain may be the way to help with that sort of stuff.
And in terms of, we do worry about AI, but it can play hand in hand if it's managed, as you say, with something like blockchain. But when you're looking, further out than this week, or let's talk about 2 or 3 years. I used to say 5 years, but it's way too far ahead because technology is moving so quickly. What are you optimistic about? What do you think is good stuff that could come down the track, and what are you a little bit more worried about?
Yeah, I think stable coins are going to be a big thing that's going to happen.
Stable coins.
Yeah. So cryptocurrencies that don't fluctuate like mad, like Bitcoin. They are pegged to some commodity like gold or silver, or they're pegged to a fiat currency like the US dollar, the euro. I think we're going to see that coming through quite a bit. And what that's going to do for us, I think, for the consumer, is that it is going to bring down lower fees. So, if I can use an Amazon coin and trade with Amazon and buy goods and services, I don't need to use my credit card. And I can maybe, have things bought for cheaper, because the credit card companies obviously take a cut in every transaction. If that cut is reduced because we're trading directly with Amazon, then of course, things become cheaper. So that could be one thing that could benefit end consumers, where prices come down on products because of the fact that we're pretty much cutting out the banks. And the banks are a bit afraid of this, of course. Yeah. And they're also trying to bring out their own stable coins into the mix, because they see this market being disrupted by these cryptocurrencies that are coming down the line.
And the cryptocurrency is in a way, it's the security of it and the safety of it that makes it attractive, I'm guessing.
Yeah, the stable coin is stable, as the name suggests. So you're not going to have a stable coin that was worth $1 10 minutes ago and 50 cents in the next hour. Yeah. And that's what worries people. So if you have a stable currency like that, and it's a digital currency, then people will have much more faith in that, and they'll start using it.
And so in terms of things that you think we need to keep an eye on, and let's look at it through the public sector lens. I know security and ID is one thing. Is there anything else you're looking at and thinking that it could be potential risks?
Well, one is, of course, and everybody's worrying about it, not just the public sector, but everybody. And this is quantum computing, of course, So quantum computers, if they become a reality tomorrow, all the crypto that we have today, such as you securing your credit card when buying stuff from Amazon or any other retailer online, is broken, immediately broken. So what's happening for a lot of governments and people like that, they're worried about this fact of harvest now and decrypt later. So any sensitive information that they're sending over open channels today, which is encrypted and secure, could down the future in the future become available to malicious actors if a quantum computer became available.
Okay, so in the old-fashioned word, it might be, let's say we're at war, with Germany, and we're keeping all of the messages that are coming through. We can't understand what they're saying yet, but one day we crack it and everything's revealed. So you're saying the same in the sense of the data that's been collected, or even conversations, whatever.
Absolutely,
going on. That's encrypted could be compromised. With quantum.
With a quantum computer. But the crypto community has been thinking about this for the last 20 years. And along with standards organizations, there have already been crypto algorithms that have been developed which cannot be broken by a quantum computer, in theory at least, because we don't have one at the moment.
Yeah.
We just don't have one. So there are other mathematical techniques that have been used to build algorithms now that will hopefully be secure even with a quantum computer around. The problem with all of those is that those algorithms that we're now bringing into these systems like browsers and email clients and so on are slow because they use much harder mathematics and much larger key sizes and so on.
Okay. So how does that impact on us in a practical way?
Yeah, so if you think about it, if you just log into any site today, the connection is totally secure. It's using classical crypto techniques. And it's instantaneous. You type in www.amazon.com and you're logged in immediately, right? And that's a totally secure connection. And that's at lightning fast speed. And that's what users are accustomed to. But with these quantum, post-quantum crypto algorithms, things become slower. Yeah. And that's where a lot of the focus is, to try and kind of make these as quick and efficient as possible so that they are on par with what we're experiencing today.
Okay, so lots of stuff coming down the track, right? Yeah. And if somebody wanted to contact you and learn more, I think they can get you on the Trinity site, I think, or they can get you on the ADAPT Research Centre.
Absolutely, yeah.
Yeah, and what's the adaptcentre.ie, right?
Yes, correct.
Yes, and LinkedIn.
And LinkedIn as well.
Well, look, thank you so much for coming in and joining us today and kind of opening our eyes to things we haven't been thinking about really, or maybe we haven't been giving enough attention to. So thank you again.
Thanks for having me.
Okay, so before I go, I just want to thank the team behind Transform Gov here in studio. It's Peter Rice, video editor Neil Horner, and sound engineer and videographer today, that's Lee Brennan. So thank you for listening, and we look forward to seeing you on the next episode.